You don't have to pull out your formula sheet, but if you do have your formula sheet handy, you will see that I actually wrote Pascal's triangle out for you on that sheet, okay? Pascal's triangle is a pattern of numbers starting with 1 at the top, and the number 1 runs along the sides or the exteriors of the triangle the whole way down. But then we start filling stuff in. So the first row, actually, this is not considered the first row, okay? This is actually considered the first row, okay? And I forget what I wrote for you on your formula sheet. Do I have 1 at the very top, Keith? Or on the yellow sheet, do I have this written, the singular 1? Yeah. It is there. Okay. So if you want, you can amend that on your yellow sheet. The first row is actually the one with the 2 1s. Okay. You're going to erase that top row. So what we do to get to the next row, we always have 1s on the outside, but then what we do is we add the 2 digits above to get that new number. So 1 plus 1 is 2. Okay. So the next row down, you would add the 1 and the 2 to get the 3. You'd add the 1 and the 2 to get the 3. And always 1s on the exteriors. So 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. So you always just add the 2 numbers above it to get that number down. Okay, that's the pattern. Now, what this is used for is to expand binomials. So say, for example, I asked you to take a plus b, a binomial cubed. You did this in Foundations 10. You don't have to write this part down. But in Foundations 10, a plus b cubed means that, right? 3 times. So what you would have had to do is you would have had to FOIL that guy, get a trinomial, and then take that trinomial, the 3 terms, and distribute each of those 3 terms into that third binomial to get 6 terms, simplify. It was quite busy and complicated, okay? What Pascal's triangle does for us is it spells out for us what the answer is going to be, okay? So you'll notice if I take a plus b cubed, it will result in 4 terms, okay? And if you look at your coefficients, 1, 3, 3, 1 corresponds with a row of Pascal's triangle. Okay? If I asked you to take it and put it to the power of 4, that's gross. We wouldn't actually want to expand that. But if you look, it results in 5 terms. And if you look at the coefficients, 1, 4, 6, 4, 1 corresponds with a row of Pascal's triangle. So Pascal's triangle kind of expands binomials for us more or less by giving us what the coefficients are. Okay, now here's some important rules, and this is going to seem like a lot of information coming at you. It is, but as we do the examples, you'll get the hang of it. So just try not to get overwhelmed. Okay, first thing, there is always 1 term more than the value of the exponent. So what I mean by that, if the exponent is 3, you'll have 4 terms, 1 more than the exponent. If the exponent is 4, you should have 5 terms. If the exponent is 27, you know you would have 28 terms once you actually expand it. Think about it. Think about something you've done a million times. If you were to actually boil that out, how many terms would you get? A trinomial, 3 terms. So it's always 1 more than the exponent is how many terms you have. Got it? Okay, that's the first little nugget. Next little nugget. The coefficients of each term come from the corresponding row of Pascal's triangle. We just talked about that. So what I mean by that, if the exponent is 5, so if the exponent is 5, whoops, we know there should be 6 terms, but we still look at row 5. So whatever the exponent is the row you look at. So like I've already said, this is our first row, our second row, our third row, our fourth row, our fifth row, and so on. So because my exponent here was 3, it would correspond with row 3. So whatever your exponent is the row you look at. And the row you look at should always have one extra term. It should have 4 terms if the exponent is 3. So everything's making sense, but it's very important that you erase that top row so that works out. Okay, next. The exponents decrease for A and increase for B. So what I mean by that, if we go back up here, your first term is going to start with the highest exponent of A and only A. The next term, it will decrease by 1, but then B will magically appear. The next one, A will decrease by 1 again, and B will now decrease because it was at 1 before, so now it's at 2. So as A goes down, 5, 4, 3, 2, 1, B increases 1, 2, 3, 4, until we're at our last term, which would have our highest exponent of B and no A's. So A goes up, A goes down while B goes up. Okay. Now, if I ever ask you to just find one term, so if I ever ask you in A plus B to the power of 5 to find the third term, if I just ask you for one term, you don't have to expand the whole thing. I just want one singular term. You use this formula. That looks gross, doesn't it? That looks really gross. Okay, there's a ton of variables, so I have written down what each variable means. When you see an n there and there, n is the exponent. So the exponent we're dealing with on the binomial. Okay, fine. K is 1 less than the term you're looking for. So if I ask you to find the fourth term, your K would actually be 3. So the K is always 1 less than the term you're actually looking for. A is the first term of the binomial, right? Usually our binomials in general just look like that. So A is the first term in the guy, and then B is the second term. That's pretty simple. And then you'll notice there's that combination button at the front. So we would use our calculator and just press that button if you have the button, right? Okay, so that is a lot of information. Let's actually apply it now. We're going to start pretty basic. I want you to just find me the next 2 rows in his triangle. So I'm just going to write out the last row I gave you, just so I have a visual. I don't have to keep scrolling up. So the last row I gave you up on your sheet there was 1, 5, 10, 10, 5, 1. I want us to find what the next row would be. So I know 1's always flank. And then I just go through and add. So the next number would be the result of 1 and 5. The next number, the result of 5 and 10. 10 and 10 is 20. 10 and 5, 15. 5 and 1, 6. And then I flanked with a 1. Okay? So don't let Pascal's triangle scare you. It asked me for the next 2 rows. So I'll do one more. Flank with 1s. Add 7, 21, 35, 21, 35 again. 21 and 7. Okay. All right, so that's how you would find the next couple of rows. All right, now what I want us to do is rewrite the 4th row, but using combinations. Okay, so I'm just going to write down the 4th row. The 4th row would be the one with 5 terms. So the 4th row up top there was 1, 4, 6, 4, 1. All right. So I want to rewrite this using combinations. We know that combinations, when I say combinations, I'm talking about this guy, right? What we did yesterday. Okay. And just a few reminders, if we're using combinations, if we're using NCR, N is the exponent that was given to you above. So N is the exponent, or in other words, the row number. okay? Now, if we just recall very quickly the formula from yesterday for NCR, this is in case you don't have the button, right? Remember, the formula yesterday for NCR was n factorial over n minus r factorial, r factorial. Sorry, I was confusing it with NPR for a second. So n minus r, right? Okay, we good? All right. Now, if we actually look at the formula that we're using today, do you see how R is replaced with K? Okay, so we have to remember that too. When we're doing the binomial theorem, we're actually going to be using K in that position instead of R. So just to remind you, K, I wrote this above, so you don't have to write it again. K is 1 less than term you're looking for. That's up in your notes above, so you don't have to recopy this. All right, so these guys right here, we're actually going to use K's instead because we don't know what R is because this is an actual combination word problem, right? So that's why we're going to use K. Okay, let's go back here now that we've refreshed all of that. Okay, so if I want to use that little formula here, okay, it would be NCK. All right, so let's fill that in. N is the exponent or the row number. I told you in the question we're on the 4th row. So N would be 4. And then K is 1 less than the term you're looking for. Well, this is the first term. So 1 less than 1 would be 0. So on your calculator, you would use or press 420. And you should get the answer of 1. Right? So I'm essentially proving to you that it works. We know it should be 1. We're just proving it. 4 would then be, again, it's NCK. N is going to be 4 the whole way through because we're on the 4th row the whole way through. But now, because I'm looking for the second term, it has to be 1 less than that for my K. And when you go 4, choose 1 on your calculator, you will get 4, which we should. It's working. All right, and we keep going down the line. This would be 4, choose 2, 4, choose 3, 4, choose 4. You plug those all in, you would get 6 here. It works. 4, choose 3, 4 here. It works. And 4, choose 4 is 1 again. Okay. So if you don't have that button, remember, you just have to use this formula on repeat, remembering that your R is actually your K, and you just plug those all in instead. Okay? So that's how I'm just proving to you that Pascal's triangle works with combinations. Okay, so let's get a little bit more complicated here. Here I give you a binomial 2x plus 1, and I want us to expand that to the power of 6. So that means 2x plus 1 would be written out 6 times. And you'd have to foil and foil and foil and distribute, and it would be rank. We don't want to do that. So we're going to use Pascal's triangle to help us out. So the first thing I want you to tell me, A, is how many terms would there be? You tell me. How many terms would there be if my exponent is 6? 7. There is always one more term than what the exponent is. So we know once we expand that and FOIL that out and simplified it, there would be 7 terms. Okay, cool. B. What term is in the middle? So what they're asking, if we have 7 terms, 1, 2, 3, 4, 5, 6, 7, which one's the median or the middle? So the 4th term would be the guy in the middle. And now we continue on, and I want us to find that middle term now. Let's find that fourth term. So I'm not asking you to expand the whole thing. All I want is that middle term, that lone term. When you're looking for a lone single term, you use that formula I gave you above. Okay, I'm just gonna write that formula out for us. That formula is NCK, A N minus K, and B to the power of K. I like, personally, to always write down what I know. This is how I do things, okay? So N is the exponent, 6, right? Yeah, N is the exponent. K is 1 less than the term you're looking for. You are looking for the fourth term. So 1 less than that is 3. Your A is the first term of the binomial. So A here happens to be 2x, and B is the second term of the polynomial or binomial, which was just a 1. So we've labeled everything, and now we just plug in. All right. So NCK would become 6C3 multiplied to A, which is 2x, to the power of N minus K, so 6 minus 3. B is 1. Again, K is 3. All right, and now we have to clean that up, unfortunately. So one thing at a time. You kind of have like 3 pieces here, one at a time. So on your calculator, or unfortunately with the formula, you'd have to figure that out. So 6 choose 3. I'm just going to, for the people who have to use the formula, I'm just going to help you out a little bit here. It would look like that, because remember the formula is n factorial over n minus r factorial r factorial. So I just used my values up here, reminding myself that k and r are the same here, plugging it in. Okay. Now, this is actually 3. Okay, we know 6 minus 3 is 3. So when you take 2x and you cube it, that means it's 2x times 2x times 2x. That is 8x cubed. A very common mistake is to leave the 2 as a 2. A lot of students only cube the x, but you're cubing the 2 as well. So 8x cubed, well, and then 1 cubed, I'm not even going to write it. Who cares? It's still 1. Doesn't matter. All right, if I work this out, this factorial ends up being just 20. If you work it all out or use your calculator to just do the 6, choose 3. And so that the last step would be 160x cubed. And so this is what that fourth term would be if we were to expand that whole thing and get all 7 terms. That would be the middle term. Okay. All righty. So this time we're going to find every single term, but don't worry, we don't actually have to do any foiling. We just rely on Pascal's triangle. Okay, so when I ask you to use the binomial theorem or Pascal's triangle to find all the terms, we rely on Pascal's triangle because we know that if the exponent is 4, we're looking at row 4 of Pascal's triangle. Whoops, that was weird. Row 4 should have 5 terms. Okay, 1 more than the exponent. So if I kind of write my spaces for my 5 terms and I look at Pascal's triangle, I know my coefficients should be 1, 4, 6, 4, 1. I know that much. I know my coefficients. But the issue comes now from the A and the 2B. We have to work those into our terms too. Okay? So this is where, remember how I said your A decreases by exponent term by term, and your B increases by exponent term by term. Remember me saying that on the previous page? So now we're going to build that in. Okay? So your first term is A, right? Just A. So I know that this guy is going to have an A with the highest exponent possible. And the highest exponent possible is not 5, it's 4. The reason I know it's 4 is because my exponents have to decrease all the way down to where A completely disappears. So if I want no A in my last term, or 0, and I work backwards, 1, 2, 3, 4 would be the highest exponent I would start with. And then my B's do the opposite. My B's start with none, and then they increase. But you have to be careful here. A is just an A, so that's easy. It would be A, whoops, it would be A4, A3, A squared, A to the 1, no A. But look at your B. Your B is actually 2B in the bracket. It's not just B. So when you start plugging in your B's, you have to plug in the 2 along with it. And that would have an exponent of 1. And then you have to plug in your 2B with the exponent of 2. Then you have to plug in your 2B with the exponent cubed. Then you have to plug in your highest 2B with a 4. All right, so whatever your A and B are in the bracket, that's what you plug in. A was just A, easy enough, but that B, that second term was a 2B, so you have to plug that in. And so now what we do, oh shoot. You know what I forgot? I forgot that it was negative. It's negative 2B in the bracket. It's negative 2B in the bracket. Half the time the negative will be irrelevant because if we're squaring it, it'll go away anyway. But for a couple of the brackets, that negative stays. So pardon me, you have to also look at the symbol that comes with that 2B. Okay, so now what we could do is we go through and we clean up each term as much as possible. So the first term, 1a to the power of 4. Okay, that's just a to the power of 4. There's no cleaning up to do. Here, look at your coefficient 4 and ask yourself, is there another coefficient I can multiply it with? Yeah, there's the negative 2. So 4 and negative 2 would make a negative 8. And then you still have a cubed and a singular b. Okay, now it gets more complicated because I have a 6, but that negative 2 is squared. You see that? So this guy right here is actually equivalent to positive 4b squared. If I actually square it, the negative goes away, it becomes a 4. So now if I go 6 times 4, I get positive 24, and then I have an a squared and a b squared. All right, this guy, what is this negative 2b cubed equivalent to? A negative 2 cubed stays negative, but it's 8, and then b cubed. So now when I clean that up, I have a 4 times negative 8 is negative 32. I have an a, and now I have a b cubed. And finally, my last term, negative 2 times negative 2 times negative 2 times negative 2 would be a positive 16. And it's times 1, so it's just 16, and then b to the power of 4. And that is totally simplified and cleaned up. That would be what that big binomial would expand to had you foiled and foiled and foiled and simplified. Okay? We're going to do one more because I want to throw fractions at you. Okay? But this time, I'm only asking you for a singular term. I'm not asking you for the whole beast. Just one term, the third term. So when I'm asking you for one term, we can very easily just use this formula to find it for us. Okay? I guess I should say, if you want, if this Pascal's triangle thing was too much for you, you could use this formula over and over and over and over and over again. Like you could use that formula 5 times to find each term if you wanted to. Or you could just kind of lay it out like I did and simplify in your head. Up to you. Okay, third term of this guy. I like to state what I know. So my n is my exponent, so 7. My k is 1 less than the term I'm looking for. I am looking for the third term. So 1 less than that is 2. My a is x squared, and my b is a positive x over 2. If it were to be negative, you'd have to include the negative. That was my mistake on the last question. Okay. So now, let's just plug in what we know. So n, 7, k, 2, a, x squared to the power of n minus k. I'll do that in my head. 7 minus 2 is 5. B, x over 2 to the power of k. So it's squared. And now the skill here comes from figuring that out. So you choose on your calculator 7C2. You should get an answer for that of 21. What is x squared to the power of 5 equal to? X to the power of 10. You multiply those together. And then when you're squaring a fraction, don't panic. You just square each piece, top and bottom. So x squared over 4. Okay. So now I can see up top, I have a 21, x to the 12, 10 plus 2, yeah, all over 4. Done. That's what the term would be. You can't reduce 21 over 4. That's done. All right. One more. I want to bring a negative back into play here and see what it does for us, okay? So all I tell you here is to find the middle term of what that would be. So just remember, if the exponent is 8, that means we have how many terms? 9 terms. You always have one more. So if I have 9 terms, which one is the middle term? The 5th term. So I'm actually looking for the 5th term. Okay, let's label what I know. N is still 8. K is 1 less than the term I'm looking for, so 4. My A is the 2x, and my B, negative y. I won't make that mistake again. Alrighty, formula, I'll just write it out one last time. And let's just plug in. N is 8. K is 4. A is 2x. N minus k, 8 minus 4 is 4. B is negative y. K is 4. So that negative is going to get deleted anyway because it's the power of 4. All right. 8, choose 4 on your calculator should give you 70. 2x to the power of 4. 2 to the power of 4, first of all, is 16. X to the power of 4 is just that. And then all that happens with the y is that negative goes away. All right, so all you got to do now is 70 times 16, 1,120. And then you can't do anything with the x and the y together. You just smush them together, and that's what the 5th term would be. Okay, so I know it was a lot of information at first, but it's just using this formula over and over again. Okay, so let me just get your assignment here. There wasn't a lot of questions to begin with, but I'll pare it down a bit. It's your last assignment. Finally, Kai says, it's been torture. 542. All right, 542. I'm not going to make you do number 1. I'll make you do 4. I'll make you do 6 is harder, so we'll skip 5. You can do 6, and we'll do 7. So 4, 6, 7, that's your last assignment. do Thursday. Stop recording.